So welcome to today's session. As usual, I'm saying. Now we are discussing the Unit 1 of Advanced Computer Architecture paper, a paper which discusses the parallel computers. Right. So in our last session, we have seen a main topic. What is that? Approximated performance of a multiprocessor. That means UMA, Uniform Memory Access Shared Memory Multiprocessor. Okay, so in this today's session, we are going to discuss Nema and Nema models. So these are all the points that we have discussed in the last session. Here we took a programming segment. Here we took a programming segment from Fortran language, and we mainly considered the main processing statements over that segment. Okay, we mainly consider the three lines L2, L4, and L6, which are doing the main processing. Okay. Moreover, we consider the execution of the same programming segment on both sequential and parallel environment, and identified under the sequential environment in general, under the sequential environment with the value of n, that means the number of elements, with the value of n, that means the number of elements, array elements. Under the sequential environment, the program takes, we identify the program takes 2n steps, that means 2n cycles. Okay, we also discussed with an example. We also discussed with an example with the number of elements equal to 2. Okay, so for a number of elements 2, the sequential version of the program takes 4 steps, that means 4 cycles we identified. Right. Thereafter, we consider the same concept, parallel version of same concept with the partitioning. Partitioning means what? Partitioning the number of statements into equal number of processes with the n by m ratio. And there we identified a statement. What is that? Do all statement uniformly distributes. Okay, uniformly distributes all the processes. That means the three main processings. Three main processings to all the processes. All the processes available on UMA, shared memory, multiprocessor computers. So here we identified L cycles are needed. Okay, as an example, we took in such a way for the number of elements 2 with the 2 processors, microprocessors, with the 2 microprocessors, m equal to 2 and n equal to 2. There we identified as a total of 1 cycle is needed. That means 2 cycles is needed. 2 cycles are needed. 2 into L, 2 cycles are needed. There we identified. So in short, we summarized with the concept. We concluded the concept with a summarization. What is that? The execution of parallel version produces the result at 50% fast than the sequential version. On your book, there are variations. There the number of inputs will differ, even the cycles will differ. Here I explain this concept with a simple example with the n, that means number of elements equal to 2. Even I mainly consider the main processings, the 3 processing, adding of BI and AI elements, that means arrays, and the initialization of some variable, and summing the A of I. Okay, so here I only took these 3 concepts, and I said, even I concluded with this topic, what is that? The parallel version is 50% faster than the sequential version. So what is the meaning? Even with an example n equal to 2, the sequential version takes how much? 4 cycles. That means 4 steps to complete. The same version, the same concept, the parallel version of same concept will need 2L. That means 2 steps, 2 cycles. Okay, so 2 by 4. That is 1 by 2, 50% faster than the sequential. So we concluded like that, right? So from your examination point of view, you will be asked like this: discuss the architecture of Nema model on 5 mark. That means section B, or the same concept will be asked with, like this: discuss the concept of Nema model with the performance, approximated performance. So under that concept, we have to discuss the architecture first. Thereafter, you have to explain this. Okay, so both architecture and this approximated performance, these two concepts are asked in 10 mark questions. So what about the other concepts? That means the way of asking questions. UMA is also asked with a split, as a split on 10 mark. Discuss the architecture of UMA as a split and the concept that we are going to discuss today, Nema or Coma. Or even the question is asked like this: write a note down, give a detailed note on UMA, Nema, Coma. Okay, so it's a expected big question. It's a expected big question, 10 mark or 5 mark questions from the first unit. So you make a note of this, right? So now we are in a stage to discuss non-uniform memory access model, that means Nema model. So what a Nema model is, in short, what a Nema model is. Non-uniform memory access, that means Nema is a shared memory multiprocessor, okay, on which the accessing time of memory will vary with the location. So that's why it's called as, referred as non-uniform memory access shared memory multiprocessor. So what I'm saying, you see, under the uniform, even you can differentiate this with the UMA and the Nema. So what the UMA model is, under the uniform memory access model, the way of accessing memory is same for all processors. Under UMA, all processors are having equal rights. Even all processors are accessing the data from shared memory with the same time. So the accessing time of processors on UMA model is same. But here, under the NUMA, non-uniform memory access memory multiprocessor, the accessing time will vary. Okay, so you see the definition once again: NUMA is a shared memory multiprocessor in which the access time varies with the location of the memory. That means memory weight, the content. Okay, so here the accessing time will vary, and that's why it's called as, what is the NUMA model. So there are, again, there are two NUMA models. Under the NUMA, as in the case of UMA, there we categorize into two concepts. What is that? Symmetric, asymmetric. Like that, within UMA also, we are going to classify the computer model under two categories. Two types of NUMA models are available, that is in use. So what are all them? So these two are the classifications of NUMA, non-uniform memory access shared memory multiprocessor. So there are two varieties of NUMA itself. Make a note of this. So two varieties, two types of NUMA models are in use, available. So what are all them? Shared local memories and hierarchical clustering models. Okay, so what about shared local memories? In shared local memory model, the shared memory, there is a memory, so mind it, all the models of shared memory multiprocessor are working on the memory accessing, based on the memory accessing. Okay, based on the memory accessing, we are classifying the shared memory multiprocessor. So here the main point to be considered is where, in the case of shared memory multiprocessor, the main point is to be considered is, what is that? The way of accessing memory, the way of sharing memory. So all the models, all the shared memory multiprocessors are classified based on the way of accessing the shared memory. Okay, so it's a common point to all types of shared memory multiprocessors. So once again, I'm saying, under the UMA model, all the processors are having uniform access timing. That's why it's called as uniform memory access. That means UMA, shared memory multiprocessor. Under the NEMA, non-uniform memory accessing, under the NEMA shared memory multiprocessor, the accessing time will vary with the location of memory rate I said. So here there are two categories. So in the shared local memory model, the first variety of NEMA, shared memory is physically distributed to all processors. You follow what I'm saying? Suppose the NEMA type is shared local memory model. A parallel computer is there. So once again, I'm saying an example, practical example to you. There is a parallel computer of the type NEMA. Even the NEMA model is what is that? The parallel computer is using shared local memory. So under the shared local memory NEMA model, the entire memory, entire shared memory is physically distributed. So what is the meaning, sir? It is not shared, it is distributed as a local memory to all processors. You see the diagram, then only you can understand. I will show that. So you just have this point on your mind. Under the shared local memory model, the available shared memory is physically distributed to all processors. Okay, all processors as local memories. So that's why it's called the shared local memory model. Okay. So you have to note the word distributed. Distributed means what? You have to note the word distributed. So what is the meaning of that? It is allocated. There is a memory, collection of memory, shared memory, and all the parts of that memory, that shared memory is distributed to all processors. So under the shared local memory, so what is the meaning? It is allocated. Certain parts of locations of shared memory are allocated to where? To a processor. For example, you take a shared memory on shared local memory computer. It is having some 100 locations. As an example, I'm saying the shared memory is having 100 locations, and there are 10 processors. Okay, you follow? The shared memory is having 100 locations, and there are 10 processors. Then the first 10 locations are allocated to where? To processor 1. Then the next 10 allocations are allocated to the next processor. For example, location 1 to 10 are allocated to processor P1. Like that, 11 to 20 are allocated to P2. So in such a way, all the processors are allocated. That means distributed with a shared memory location. Okay, so what is the actual meaning? The processor one is always utilizing which one? The locations from 1 to 10 as a local memory. For main processing, a processor one is always using locations 1 to 10. Like that, the processor 2 is using from where? From location 11 to 20. So they are privately using it as a local memory. So that's why actually the model is called, what is that? Shared local memory model. Sometimes processor P1 tries to access the other distributed memory of remaining processors. For example, P1 would like to access a location from the P2, the allocated location of P2. For example, P1 likes to access the value from location 15. So what is it? Locations from 11 to 20 are allocated for processor 2, I said. So in such concept, the processor 1 P1 is trying to access the location 15. So this is called, what is it? Remote accessing. Okay, so under the first memory model of NEMA, the available shared memory is distributed to all processors. Okay, so the processors are utilizing the distributed memories as local memory. So that's why the model is also called, what is that? Shared local memory model. So the distributed collection of local memories, that entire local memory, forms the global address space. For the remote accessing, just now I said, processor 1 would like to access the location of processor 2. So under that aspect, the entire collection of local memory is kept as a global address space concept. So through the global address base GAS, remaining processors are accessing the locations of, that means the local memories of other processors. Okay, so within this model, shared local memory model, there are two types of accessing of memories: local memory access and the remote memory access. Local memory access means what? A processor just accesses its allocated distributed memory location. So as an example, once again I'm saying using P1 is accessing the location 8. So what is it? Location from 1 to 10 are distributed for P1. So now P1 is accessing the location 8 in the sense, what is the meaning? It is accessing the local memory. So which is somewhat fast because it directly accessing its own memory. Okay, so suppose once again P1 is trying to access this one. P1 is trying to access location 15, that is remote accessing. So it is taking some timing. So you see the last point, local memory is accessed fast, whereas the remote memory accessing, the task, is taking timing because the request has to be sent to the global address space, and the global address space is giving permission to access the remote memory of other processors. Okay. So you see it on the diagram, now you can understand easily. You see, it's the architecture of shared local memory type of Nema model. Actually, this one was practically implemented by a corporation, a computer company, VBN Butterfly Company. Okay, so which formed this model, shared local memory model of Nema, the first type of Nema model. So there you say LM1, LM2, up to LMN. So what are all them? They are the shared memories. You see the diagram? Just to remember the point I said, under the shared local memory architecture, the entire shared memory is distributed to all processors I said. So now here you say the local memories from, that means the shared memory, entire shared memory is distributed as local memories to all processors like this LM1. LM1 means what? It's a group of locations allocated to processor 1. LM2, another set of locations allocated to processor 2. Like that, one more set of locations that is allocated to processor N. So now you say the processor 1 can easily access locations from LM1 because it is local to its local. Like that, P2, processor P2, that is directly accessing location from LM2. Okay, then you see a box, a larger box, interconnection network. So what about this? It's a connecting mechanism which connects all the locations. That means all the group of shared memory and it forms the global address space GAS. Okay, suppose now you see once again I'm saying the same example. P1 is trying to access a location from LM1. It can easily access because it is directly connected. So the accessing time is fast. Suppose P1 tries to access LM2, the location from LM2. Now the P1 has to send a request to interconnection network. Now the PM has to send a request to where? You see the mouse pointer, P1 has to send a request to where? Interconnection network. Now the interconnection network finds the address of the location requested by the P1 and it identifies the location is where? On LM2. So now it maps, it forms a global address space and give permission to P1 to access the location of LM2. So this will take timing. That's why I said local accessing is fast, whereas remote accessing is taking timing. So it's a one variety of Nema model. Okay. So next we'll take the hierarchical clustering model. Next we'll take the hierarchical clustering model. So under the hierarchical clustering model, it's the second variety of Nema model. So under this hierarchical clustering model, all the processes are arranged as clusters. So what is the meaning of clustering? I think you are having a paper, data mining. So under that there is a concept clustering. Basically what a cluster is, clusters means a group. Very simple. What I'm saying, you see, cluster means what a cluster is, it's a group. Group of quantity is called as cluster. Okay, so under this model, hierarchical clustering model, all the processes are arranged as clusters. That means groups. Okay, so within this hierarchical clustering model, there are three levels of memory accessing. I already told you the shared memory multiprocessor is classified based on the way of accessing the memories. Okay, so by considering that fact, within the hierarchical clustering model of Nema, there are three levels of memory accessing. So what are all them? First one is the local memory access. Next one is the global memory access. And the last one is the remote memory access. That means other processes can access the locations of remaining. Okay, so there are three levels of memory accessing available within the hierarchical clustering model of Nema. So this might be asking two more questions. Okay, write the three levels of memory accessing in hierarchical clustering. List the level of memory accessing within hierarchical clustering. So you have to say this: local memory access, global memory access, and remote memory access. Okay. So what is the first point about this hierarchical clustering model? All processes are arranged as clusters, I say. So during the formation of clusters, that clustering concept can utilize either Nema architecture or the Nema itself. You follow what I'm saying? The entire model now we are discussing is what is the hierarchical clustering model. Okay, the current model that we are discussing is what is the hierarchical clustering model. So under the hierarchical clustering model, all the processes are clustered. I'm saying all the processes are arranged as clusters. During the clustering process, that means during the grouping process, processing of processes, the processes are arranged by using the Nema architecture or Nema. You follow this? Again, I'm saying during the formation of each cluster under the hierarchical clustering, every cluster utilizes Nema model for arranging the processes. Every clustering process uses Nema model for arranging the processor, or it may use which one? Nema. Okay, so by either using Nema model or Nema model, the clusters within the hierarchical clustering model are formed out. Okay, so after the formation of the cluster, each cluster, not processes, mind it, after the formation of the cluster, what a cluster is, it is having a collection of processors. So after the formation of cluster by using Nema or Nema, okay, each cluster is each cluster is connected to the global shared memory model. That means GSM. So now, after forming the clusters by using either Nema or Nema model, and even after connecting that formed the clusters with the global shared memory models, now all the processes within each cluster are allowed to uniformly access the memories. Which memory? The global shared memory model. So under this, here we said there are three levels of, what is that? Three levels of memory accessing. So under this, The accessing of global shared memory, that means global memory access takes more time than the other memory accessing, that means local memory and the remote memory access. So now you see this diagram. You just see this. Again, I am reminding you, while seeing the diagram, you have to put your mobile phone in landscape mode, then only you will get a full screen view. Don't put your mobile on portrait mode. Okay, suppose you are putting your mobile in portrait, it means horizontal position, horizontal orientation, you will get off of the screen. You are not getting the clear view of pictures. So you put, while viewing, even generally it's better to view the classes in landscape mode, that means in horizontal mode, as a full screen view, right? So now you see this diagram, enter diagram. So here there are number of times. Here there are number of times. So what are all them? Cluster 1, cluster n. So you see cluster 1 and cluster n. So what a cluster is? We know well, cluster is the collection of processes, arranged processes. So here each cluster is formed with either UMA or Nema model. Then on each cluster there are processes and the CSM. So you see what a CSM is. So on the side, I will actually have given the legends, the explanation of legends within this diagram. What a CSM is? Cluster shared memory. So on each cluster, there are processes and the cluster shared memory provided with a concept of CIN, Cluster Interconnection Network. So here the CIN, Cluster Interconnection Network, connects each cluster shared memory. Okay, so you see the same thing will happen on every cluster. So above each cluster, there is a global interconnect network, GIN, and the GIN is connecting this one, GSM, global shared memories. So within this, there are 3 levels of memory. CSM, that means cluster shared memory. The CSM is acting as a local memory for corresponding processor. You see on diagram. For example, you see the mouse pointer. Speed, the first processor, you see the cluster 1. The processor 1 on cluster 1 is directly connected with which one? The corresponding CSM. So now the first CSM is acting as a local memory for processor 1. Okay, so that clusters, actually they form the clusters are connected with the global interconnect network, and the global interconnect network is providing memory accessing to each cluster that is intent to write each processor within a cluster. So what is going on within this architecture? Within this architecture, each processor is allowed to access its local memory, the corresponding memory directly against it. Okay, in the other side of CIN box. At the same time, the processors within each cluster are allowed to access CSM, that means cluster shared memory. You follow? Processors within clusters, each cluster are allowed to access CSM. Okay, through the CIN, the processors, that means the cluster is allowed to access the GSM. Mind it, no processor is allowed to access CSM from other cluster. There is no connection, you see here. There is no connection here. Okay, so it's a model. What is that? Hierarchical cluster model. Even it seems like a hybrid, that means hyper model, hybrid model. The hybrid model of Nema, followed at SEDA system in the University of Illinois. Okay, so it's the other variety of this one, Nema. So there are 2 varieties of this one, Nema models we have seen. So only one model is there. What is that? OMA. So we will discuss the COMA model in the next session. So after discussing the COMA, we'll have to proceed with which one? Distributed memory accessing multi-computer. Okay, students, now we'll wind up today's session. We'll meet you on another session. Thank you, Ananda.